So just like with mirrors, what we want to do with lenses to start off with is we want to do this in a non-mathematical way or a graphical way. So we're going to look at ray diagrams. Similar to with mirrors, we're going to show you how to do three rays. In reality, you only need to really know how to draw two of them, because once you find the intersection of two refracted rays, you will know where the image is formed. You're good to go. Now, those characteristics we talked about with curved mirrors, like magnification, attitude, position, and the type of image, those still apply with thin lenses. They still have the same definition. Nothing has changed. So just before we get into this, with converging lenses, kind of like what we did with concave mirrors, we gave various positions of where the object is placed relative to the mirror. In this case, we're doing it relative to the lens. And this is just telling us the image characteristics of that image that's being formed in the lens. Diverging lenses are very similar in the sense to convex mirrors, in that convex mirrors always produce diminished, erect, and virtual images. Same thing with a diverging lens. The images will always be diminished, erect, and virtual. So they're not particularly interesting. So in terms of drawing the ray diagrams, for a converging lens, the first ray that we could draw, we would draw it parallel to the principal axis. We'd go towards the optical center of the lens, so you can kind of see this dashed line representing the center of the lens, and then the optical center is right in the middle, so I guess I shouldn't use the word optical center yet. But anyways, we're just going to draw the first ray towards the center of the lens where it's cut in half, and then we're going to refract that ray through the focal point on the other side of the lens. The second ray, what we're going to do is we're going to pass it through this focal point on the same side of the lens as the object. We're going to have it go towards the center of the lens, and then once it hits the center of the lens, it's going to refract parallel with this principal axis. I really don't recommend drawing the second ray. It just ends up being complicated and frustrating. So I would always say draw the first ray and then draw the third ray. The third ray, you aim it to the optical center of the lens. No refraction necessary. You just continue extending that straight line. Done. No problems. So for these, I always recommend the first and third rays for converging lenses. As you can see with diverging lenses, kind of the same idea. So the diverging lens, our first ray, we have it parallel to the principal axis, and then it's going to diverge away, but it's going to diverge in such a sense that if we extended that diverging ray backwards, it would look like it originated from this focal point on the same side of the lens as the object. The second ray, again, a little bit complicated. We're going to draw that ray aiming towards that focal point on the other side of the lens, but once we get to the center of the lens, it's going to refract parallel with our principal axis. And then, of course, we could take that refracted ray and extend it back into virtual territory if necessary. So I really don't recommend the second ray for diverging lenses as well. And then the third ray, we just pass it through the optical center of the lens and continue going. No real thought necessary. So for all the lenses, I recommend drawing the first and third rays, and that's what I'm going to do for the next couple of examples, just because those are the easiest to deal with. So we have the following diverging lens. So we want to determine the image and its characteristics. So I have this object, and I want to see where the image is formed. Now, we know for a diverging lens, we know it's always going to produce an upright image, we know it's going to be erect, and we know it's going to be virtual. Let's see how we can find this with our ray diagram. So the first ray I'm going to draw it parallel with this principal axis here. So we're going to draw that light ray, and then we're going to get to the center of the lens. Now, when this diverges, we want it to diverge such that if we extended that ray back, it's going to look like it's coming from this virtual focal point, or this focal point on the same side of the lens. So what we're going to do is from the focal point to the lens, we're just going to draw dashed rays because these are virtual rays. And then once we get to the lens, we'll draw that diverging ray. So that's our first ray. You could go ahead and draw the second ray. You could aim it towards this focal point, but once it hits the lens, have it go straight and then go backwards. That's a lot of work. How about we just go right through the optical center of the lens? This is much easier to deal with. So I go here, go there, done. Much easier. No thinking required. So what we're going to see here is we're going to see that intersection of these rays at about here. So if I did all my light rays from the tip of the arrow of the object, then where they intersect is going to be the tip of the arrow of my image. So having the grid paper here is certainly very helpful. We can assess magnification a lot easier because we can see our object's 2 units high. Our image is less than a unit high. So for sure this has become diminished. And this is consistent with what we said earlier, so that's good. Attitude, the image is upright relative to the object. That's confirmed, very good. And then position, again we said for position, we'll kind of be a little vague on this just with the ray diagrams. Once we do the math, we can get it more exact. I'll just say it's between lens and F. I'm not too worried about the exactness for now. And then the type. So when we talked about mirrors, we said that if the object and the image are on the same side of the mirror, that would be a real image. For lenses, it's the opposite. If the image and the object are on the same side of the lens, this is actually going to be a virtual image. Just because the rays that are actually, the refracted rays that are actually converging here, it's an extension of the real refracted rays. So these are virtual rays that are intersecting. So we can do the same kind of thing for converging lens. So this time we have a converging lens. The object is well beyond this twice the focal point. So let's start out with the first ray. First ray we're going to draw it parallel with the principal axis, and then we're going to draw it to the center of the lens. So we're going to have this. So there's my first light ray. Now when it gets to the center, we want it to pass through this focal point over here. So we're just going to aim that to the focal point, draw that light ray, done deal. So here's our first ray. Passes parallel, refracts through the focal point, done. You could draw the second ray if you wanted, but like I said, I like things easy. We're just going to draw it right through the third ray, and we're going to draw it right through the center of the lens and continue on. So with this here, actually I better get my bigger ruler for this. So I'm going to get my really fancy ruler for this one here. So we're going to draw something that looks a bit like that. So here is my third ray, or my second ray that I've drawn. So we see that we have an intersection point over here. So here's my intersection. So this is going to represent the tip of the arrow of my image. So now let's look at this. In terms of the magnification, our object is 2 units high. This one is not quite 2 units, so it's a little bit smaller. So we're going to say it's diminished. In terms of attitude, the image is inverted relative to the object, so we're going to say it's inverted. Position, again, vagueness, just for the ray diagrams, it's between F and 2F. If you're someone who'd like to say, like, well, it's, closer to 2F, or, it's, you can even count it 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 units away from the lens, that's fine. For ray diagrams, we're not looking for exactness, we're just looking broad strokes. And then the type. So if the image is on the opposite side of the lens relative to the object, this is going to be a real image, just because these are the actual real light rays that are intersecting after they refract. So that's kind of the gist of ray diagrams for lenses. We're going to show you one more case in the next video, the special case. We showed you kind of that tricky one they did with mirror, with a concave mirror, when you had the object placed between the mirror and the focal point. We're going to kind of do something similar with a lens when we place the image between the focal point and the lens itself. So stay tuned for that.